Hello students, I'm your tutor Syed. In today's session, we'll try to take one example. Let's get started. The question is, find the value of the constants a, b, c such that vector f is equals to x plus 2y plus az times of I plus bx minus 3y plus z times of j plus 4x plus cy plus 2z times of k is conservative. Also find its scalar potential. So he's asking us to find out the values of A, B, and C such that this particular vector F is conservative. What does this vector F is conservative means? Vector F is conservative. So vector F is conservative means that curl of vector F is 0. That means vector F is irrotational. Vector F is irrotational. So if vector F is irrotational, we say that vector F is conservative. So since he has given vector F is conservative, vector F is irrotational. So if vector F is irrotational, curl of vector F is 0, or curl of vector F can be written as del cross vector F is equals to 0. So now taking this del cross vector F is equals to 0, we have to find out the values of A, B, and C. So curl represents the determinant. Let us write down the determinant. Determinant I, yeah, the first row is I, J, and K. Second row represents del values. There is coefficient of your I value will be dou by dou x. Coefficient of J value will be dou by dou y. Coefficient of K value will be dou by dou z. Since you know that del is equals to dou by dou x of I plus dou by dou y of j plus dou by dou z of k. I'm just writing down the coefficient of I, coefficient of j, and coefficient of k. Then the last row, you have to write down the coefficients of I, j, k of vector f. So here you are having vector f, coefficient of I, j, and k. Coefficient of I is what? X plus 2y plus az. Coefficient of j is what? Bx minus 3y minus z. What is coefficient of k? 4x plus cy plus 2z. This determinant is equals to 0. So now let us try to expand this along the row. So this is plus, this is minus, and this is plus. So if we try to expand this one, plus I times off. So for that, you have to close this particular row where I is there and the column where I is there. So if I close the row and column, all right. So let me close this particular row and this particular column. So what will be left out? Will just be left out with these values. You need to cross multiply this one. So let's multiply. It is dou by dou y of 4x plus cy plus 2z minus again dou by dou z of dou by dou z of bx minus 3y minus of z. So with I, you're done this one. Then minus of j you're having minus j times of. Now j, you have to close this column of j and row of j. Then you just cross multiply this one, dou by dou x of this value and dou by dou z of this value. So we write down, it is dou by dou x of, what will be getting? 4x plus cy plus 2z. Then minus of this dou by dou z of this value. Dou by dou z of x plus 2y plus az. Then j times of this we have got. Then plus k times of. Okay, you have to close this column where k lies and the row where k lies. Again, cross multiply this one. So what will be getting? Dou by dou x of bx minus 3y minus z. Then minus of dou by dou y of x plus 2y plus az. So expansion is over. That is equals to what? That is equals to 0. Now let's try to simplify this one. So plus I times of, you have to differentiate this partially with respect to y. When you're trying to differentiate partially with respect to y, this 4x is a constant. Its derivative will be 0. Plus c into derivative of y with respect to y will be 1. So c times of 1 will be c plus partial derivative of y with respect to z. So when you're trying to differentiate with respect to y, z is a constant. So 2z is a constant, its derivative will be 0 minus. Now we are trying to differentiate partially with respect to z. So when you're trying to differentiate with respect to z, which is constant, x and y is constant. So here x is constant, therefore its derivative will be 0 minus. Here y is again a constant, its derivative will be 0 minus. Derivative of z with respect to z will be 1. Then minus j times of. Now here you differentiate partially with respect to x, which means y and z will be constant. So you have 4 times of derivative of x with respect to x will be 1. 4 times of 1 will be 4 plus here y is a constant, derivative will be 0 plus z is a constant, derivative will be 0 minus. Now it is dou by dou z off, which means that when you're trying to differentiate partially with respect to z, x and y are constant. So first term x is a constant, its derivative will be 0. 2y constant, its derivative will be 0 plus a into differentiation of z with respect to z will be 1. So a times of 1 will be a. Then plus k times of. Now here you have to differentiate partially with respect to x. So it is b times of derivative of x with respect to x will be 1. But derivative of 3y, y is a constant, derivative is 0. Then z is a constant, derivative will be 0 minus. Now it is dou by dou y off. So when you're trying to differentiate with respect to y, x and z are constant. So first term x is a constant, derivative is 0 plus 2 times of derivative of y with respect to y will be 1. So 2 times of 1 will be 2 plus a into z. Z is a constant, derivative will be 0 is equals to you have 0. Or further, if you try to simplify, it is plus I times of 0 you can ignore. C, this is minus of minus plus 1. So C plus 1 minus j into, it is 4 minus of plus will become minus. So 4 minus a plus k times of, you have b minus 2 is equals to, so now this can be written as I into 0 because it represents 0 vector. So I into 0 plus j into 0 plus k into 0. Now we can equate the coefficients of I, j and k. So let's try to equate coefficient of I. Equate coefficient of I. Left hand side coefficient of I is c plus 1. Right hand side it is 0. So which is c is equals to plus 1 goes on the other side becomes minus of 1. So we have got the first value, c value to be equals to minus of 1. Now equate the coefficient of j. Equate coefficient of j. So what is coefficient of j on the left hand side? With a negative sign here, take minus of 4 minus of a is equals to, on the right hand side, coefficient of j is 0. Or further, if you try to simplify, it is minus 4 minus of minus plus a is equals to 0. Or a is equals to minus 4 when it goes on the right hand side becomes plus 4. So you got the value of a to be equals to 4. Then further you can equate the coefficient of k. Equate coefficient of k. Equate coefficient of k. So what is coefficient of k over here? B minus 2. So b minus 2 is equals to, right hand side coefficient of k is 0. Further, if you try to simplify, b will be equals to. So when minus 2 goes on the right hand side, it becomes plus 2. So therefore, the value of b will be equals to 2. So all the values have been obtained. Hence, We got the value of A to be 4, B to be 2, and the value of C that we have got. The value of C is minus of 1. So all the three values have been obtained. So first solution is complete. But if we go back to the question, it says also find its scalar potential. So what is that scalar potential? So for scalar potential, we know this formula. We know del phi is equals to vector F. So del phi is equals to vector F. Phi represents the scalar potential. We need to find out the value of phi. So we know del phi is nothing but dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k is equals to vector F. So what is that vector F you are having? Go back to the question. You have x plus 2y plus az. So I've written the value of f. Now let's try to equate the coefficients of I, j, and k. So equate coefficients of I, j, and k. So if we equate the coefficient of I, it is dou by dou x is equals to, it is x plus 2y plus az. So similarly, we'll try to equate the coefficient of j, it is dou phi by dou z is equals to how much? It is bx minus 3y minus of z. Then the coefficient of k, so here the coefficient of x is y, dou by dou y. So here it is dou phi by dou z is equals. Now if we try to equate it is 4x plus cy plus 2 times of z. But since we know the values of a, b, and c, but the value of a is 4, the value of b is 2, the value of c is minus of 1. So let us just try to plug in those values over here. You have dou phi by dou x is equals to x plus 2y. The value of a is 4, so 4 times of z. Then you have dou phi by dou y is equals to b value is 2, so 2x minus 3y minus of z. Then you have dou phi by dou z is equals to 4x. C value is minus 1. So plus into minus will be minus y plus 2 times of z. Now since I need to find out the value of 5, let us try to integrate this. So if you integrate, you'll be getting integral of dou phi by dou x into dx is equals to, it is integral of x plus 2y plus 4z times of dx plus function of, when you're integrating with respect to x, what are the constants y and z? So it is function of the constant y and z. So first let us complete this one. If we try to integrate, integral of dou phi by dou x into dx will give us phi value is equals to, now it is integral of x into dx plus 2y is a constant, so 2y is outside, you have integral of dx plus 4z is a constant, outside it is integral of dx plus function of y comma z. Now let's try to integrate. Integration of x will be x square by 2 plus 2y. Integration of dx is x plus 4 times of z. Integral of dx is x plus f of y comma z. So therefore we have 5 is equals to x square by 2 plus 2xy plus 4zx plus f of y comma z. So we have obtained phi just by integrating dou phi by dou x. So let me take this as equation number 1. Similarly, let us try to integrate the next one. So I'll take this as, so it is better we take this as equation 1. This is 2. This is 3. And this will take it as 4. Now we'll try to integrate equation number 2. Integrate equation number 2. So if you try to integrate this integral of dou phi by dou y, because here y is there, we'll try to integrate with respect to y, is equals to, it is integral of 2x minus 3y minus z times of dy plus, if you're integrating with respect to y, what are constants? Z and X are constant. F of ZX. If you try to integrate, dou by dou y of phi will be only 5 is equals. Now let's try to integrate with respect to y. So 2x is a constant. First term is only integral of dy. Then minus 3 is a constant. It is integral of y into dy. Minus z is a constant. Is integral of dy. Plus the function of zx. So you're having 2x. Integration of dy is y. Minus 3 into integration of y will be y square by 2 minus z into integration of dy is y plus f of z comma x. Or further, if you try to simplify, it is 2xy minus 3y square by 2 minus 3y plus f of z comma x. So let me take this as equation number 5. One more equation is left out. It is dou phi by dou z. That is equation number 3. Let's try to integrate that. Integrate equation number 3. Integrate equation number 3. So we have integral of dou phi by dou z into dz is equals to, it is integral of so it is 4x minus y plus 2z times of dz plus function of, what are the constants here? X and y. So integration of dou phi by dou z will be 5 is equals to, here 4x is a constant, you will be getting integral of dz. Y is a constant, we'll be getting integral of dz. Plus 2 is a constant, integral of z dz. Plus function of x comma y. So let's try to integrate it. 4x, integration of dz will be z minus y into integration of dz will be z plus 2 into integration of z will be z square by 2 plus it is function of x comma y. So this value is z over here, z times of y, not 3. Further, if we try to simplify this one, so this 2 and 2 will get cancelled. We are left out with 4xz minus yz plus z square plus the function of x comma y. So let me take this as equation number 6. Now we need to compare this equation 4, 5 and 6 and get the required solution. First, let me compare this equation 4 and 5. If we try to observe equation 4 and 5, left-hand side values are the same. This 5, left-hand side. If the left-hand side are the same, right-hand side should also be the same. So therefore, if you try to compare the values over here, so when the left-hand side values are the same, right-hand side value should match. Now let us try to match the right-hand side values. So you're having 2xy over here, you're having 2xy. They are matching. Then you have z and x. So this z and x is involved over here. So this value will be what? 4zx. That will be matching. One more term. What about this x square plus 2? X is there involved over here. So therefore plus it becomes x square by 2. So you'll be getting two terms for f of z comma x, just comparing equation number 4 and 5. What about this particular value f of y comma z, which is missing over here? This one. So this value will be minus 3y square by 2 over here because y is there in this. Along with that, you are having minus zy. So that becomes minus of zy. So hence two values you obtained over here. So comparing 4 and 5. Comparing equation number 4 and equation number 5, we got f of yz will be equals to minus of 3y square by 2 minus of zy and f of zx is equals to 4zx plus x square by 2. These are the two values you obtain. Now let us try to compare equation 5 and 6. Comparing equation number 5 and equation number 6. So let us try to compare over here. So you can observe over here 4 zx. So where 4zx is there, 4zx or xz is there over here. It is matching, right? This particular value. Then minus yz. Where is minus yz? Minus yz is matching over here. Minus yz. Plus z square. Z square is not there. So therefore z is over here involved. Therefore, one more term plus z square has to come over here. So one more additional term will be coming over there. So if z square comes over here, here also you have to get, because both the equations should be the same, plus z square you will be getting another term. So two additional terms have been added over here. Now further, let us go for the next term. Z square is done. Then what will be f of x comma y? So what is missing over here? This is taken 2xy. 2xy will come over here. So this will be 2xy minus of. So this 3y square by 2. So minus of 3y square by 2 has to come. So only x term and y term has to come over here, right? So z term is already taken there. So what about the other term? X term and y term. What about this x square by 2 has to come here? Plus x square by 2. So this will be your f of x comma y. So can you observe all the terms are there? We'll start with this one. We'll highlight it over here. 4zx. 4zx is over here. Minus yz, and minus yz is over here. Z square. So z square and z square is matching. Then you are having, I have taken 2xy and then 2xy. Then I have taken minus 3y square by 2, 3y square by 2. Further, x square by 2 and x square by 2. I hope all the terms are taken. Can you observe? Equation 5 and 6, all the terms have been taken. So now, if you try to compare, one additional term has to be added for zx. Zx, what is another additional term we'll be adding? Plus z square for both. So plus z square for this also you have to add. Plus z square for this also you have to add. Now comparing equation 5 and 6, I've already written zx. So there is no need to write once again zx. Only I'll try to write down f of x comma y. So what is that? It is 2xy minus 3y square by 2 plus x square by 2. Now you can plug in these values in any one of the equations, either equation 4, 5 or 6. So I'll write down in equation number 4. So equation number 4 implies 5 is equals to, what is the first term we have? X square by 2 plus 2xy plus 4zx minus 3y square by 2. So now if you try to rewrite this one, so 5 will be equals to, it is x square by 2, then minus 3y square by 2 plus z square. If I'm writing x square, y square, z square together, remaining terms plus 2xy minus yz, zy or yz, minus yz, this term. Next term plus 4 times of zx. So that will be the required solution. So we obtain the scalar potential. So this represents the scalar potential. So first we have found out the values of A, B, and C, and then we have found out the scalar potential. So that's the required solution. So you need to practice once or twice to get the hold of this problem. So that's all I have in this session. Meet you in the next session. Till then, goodbye.